So in this class, what we will be discussing is about the operators in C. The operators in C, there are actually different classifications of operators in C. The operators are the symbols which takes one or more operands. Operands are the variables or the values on which the operators work. So operands are the like A plus B. A and B are the operands and plus is the operator. So the operands can be expressed, the operator can work on expressions also, like A plus B into C. A plus B is an expression, so multiplied by C. So that is another operand. C is an operand. So that's what, like this, the operators can work on expressions or operands. And the computations that is done by these operators can be arithmetic or logical computations. It can be arithmetic or it can be logical. The arithmetic is depending on the values, depending on like A plus B. If A and B are two integers, adding those two, so that is the arithmetic operation. And logical operator is something like if A is greater than B. So that is a logical condition, whether A is greater than or less than B or equal to B. So that is a logical computation. So the operands are the variables or the expressions which are used in conjunction with operators to evaluate the expression, as well as I said earlier, the A plus B. When we say A plus B, A is A and B are the operands, and plus symbol, that plus is the operator. And the combination of operands and operators, they form an expression, like as I said, A plus B. A plus B, two operators are there and one operand is there. So it is a combination of operators and operands, and it is known as an expression. So the expression can be very complex and very lengthy also, like in a long polynomial, it is an expression of a large number of items. So the expressions are sequences of operators, operands, and punctuators that specify a computation and evaluates to a single value. So normally the expressions evaluates to a single value when you add A plus B into C divided by B, something like that. So in that something like this, A plus B multiplied by C, the whole divided by D. This is an expression, but when we substitute some values to when we give values to all these variables A, B, C, and D, this evaluates to some single value, say E. So E can be equated to this value, or this value can be evaluated to this expression can be evaluated to a single value E. So the evaluation of the expressions is based on the operators that the expression contains and the context in which they are used. So how this particular thing is evaluated, this depends on the position of the operators and the context in which they are used, like this one, A plus B. So here it is given inside a bracket. So if this is different from something like this, A plus B into C divided by D. So these two are, in writing it is almost similar except this bracket. It is similar, but the values will be different, because when we put values, I mean brackets here, it means it has a different precedence of how the operators are done. The operators perform in the operands. So that is different. So when we put A plus B within bracket, that means A plus B is to be done first, and then it should be multiplied with the C. So if it is put like this, A plus B into C, it means B into C is to be done first, and then we have to do A. So then that sort of things are there. So that is the order in which the operators are to be done. The operators are to be employed depends on the precedence of the operators. That also we will see in this class, or probably in the next class. So the different types of operators offered by the C language. There are 8 different kinds. In some text they are classified into only 6 different kinds, but in many texts it is classified into 8 different types of operators. They are the arithmetic operators, the assignment operators, then relational operators, logical operators, bitwise operators, conditional operators. Conditional operators are also known as ternary operators. Actually, this conditional operators is a combination of different operators. That is, there is only a single conditional operator available, and that is a combination of 2 or 3 symbols. So that we will see. Then there is a decrement or increment operator. Then some special operators are also there. So we can see, or we will see each of these type of operators one by one. First, let us look into the arithmetic operators, which are the simplest things that we have already studied. All those things, the arithmetic operators. C arithmetic operators are mainly used to perform the mathematical calculations like addition, subtraction, multiplication, division, and modulus. There are 5 arithmetic operators. They are the plus, minus, that is the addition, the subtraction, then it can be the multiplication, the division, or the modulo division, that is the modulus. In this modulus operation, what we are getting is the modulus, the remainder of that particular division. So that is it. So if it is an addition, it is a plus b, something like this additional a plus b. The unary plus and unary minus, that I'll say later. And in the normal addition, it is a plus b. A plus b will give 30. So if let a is 10 and b is 20, so in that case a plus b will give you 30. And a minus b, so a minus b, a is 10 and b is 20, so a minus b will give you minus 10. A into b, it will give you 200. B by a, it will give you 2. So this is the modulo division, that is b percentage a. This percentage symbol denotes that this is a modulo division, or the what you say, the modulus division, in which case the remainder is given out. So b divided by a. So b is 20 and a is 10. So the remainder is 0. So when we divide b with the a, so if it is 5 percentage 2, so if this is this will return 1, because when we divide 5 with the 2, there is 1 is the remainder. So that is how these operations are being done. So these are most of these operations, not most of these operations, all the operations are by having 2 operands as required. See, here there are 2 operands, a and b are there. Here also a and b are there. Here also a into b is there. B by a is there. Then b percentage a. There also a and b are there. So 2 operands are required for these arithmetic operators. But when it comes to unary plus as well as unary minus, actually unary plus doesn't have much meaning, but it can be written like this: plus a. Plus a means whatever be the value of a, it is converted to the positive. But in the case of, you know that when it is a negative sign, a is a negative sign, even if we put a plus a here, it will be negative itself. Say a is some minus 10. In that case, plus a means minus 10 itself. It doesn't changes its value. But on the case, on the other case, if it is a unary minus means minus of a. So in this case, if it is minus of a, if a is 10, this will return minus 10 as minus of a, and if it is minus 10, this will return plus 10 as the value for minus of a. So this is unary minus. Unary means there is only a single operand associated with that one. So that is why it is unary plus. Unary means 1. So unary minus means only a single operand with a minus. So minus a. So this is the unary plus as well as unary minus. Unary plus doesn't have any effect on the operand, but the unary minus changes its sign. Whether if it is a minus sign associated with it, then it is converted into a positive sign, or it is converted into a positive integer or positive number. And if it is a positive integer, then if you put a unary minus in front of it, it will be converted to a negative value. So that is how the unary plus as well as unary minus works. So that is the arithmetic operators. So we said the integer division truncates the remainder. That is the problem. If we divide, if the division is by like the 5 divided by 2, we know that 5 divided by 2 is 2.5. That we know. But if a and b are, I mean 5 and 2 are given as integers, this will be, we will get only if there is a this decimal digits towards the right. That is, if 5 and 2 are declared as float values, then only we will get like this. If 5 and 2 are declared as integer values, that is 5 divided by 2, then this the result of this will be only 2 in case of C programming. So that is a difficulty. The integer division will give you only 2. Otherwise, if at least one of these operands should be declared as a floating point value, either 5 or 2. If one of them is floating point value, then the result will also be a floating point value. Otherwise, it will be integer itself. So that is that we have already seen in the case. Sorry, that is not described. That we will describe later. And the percentage operator cannot be applied to a float or double. So that is it. This can be, the percentage operator can be applied only to this integer values. You cannot apply percentage operator, that is the modulo operator, to float value or double value. Then the precedence of the arithmetic operators are so these two we have to see. The unary -1 first, then the star, then divided by percentage, then the lowest is the lowest priority is to plus and minus. You know the order in which the arithmetic operators are classified or are done. So you have studied this board mass rule. You might have studied in your school days. That is bracket, of, then division, multiplication, addition, and subtraction. So the expressions are evaluated in this order. That is, if there is some brackets given in that case, then obviously whatever operation within the bracket, that is to be calculated, that is to be done first. Then the of operator, that is the percentage or what percentage of something is that. Then the division operator, then the multiplication operator, then addition, then subtraction. And if some values, some operations are in consecutively, like a plus b minus c, etc., something like this, then it has to be done in the order, that is from left to right. So that is known as the associativity of operators. So the first one is the precedence. The precedence means in which order the operators are to be performed, and the second one is the associativity. Associativity is again in which order it has to be performed, and the associativity relates to operators of the same precedence. If two operators are of same precedence, then which is to be done first. And if in the case of the precedence, what it means is that in what order, that is in what order it is the operators of different precedence are to be done. So that is it. So that we will discuss later. So some we have said that the arithmetic expression is a combination of variables, constants and operators. So there can be constants also in the arithmetic expressions. The arithmetic expressions can contain constants also, like this, a into b minus c. So that means a into b minus c. So first you have to evaluate a into b, then c is to be subtracted from here. So here is m plus n into mx plus y. So that is an expression. So this means that there is this expression when we write it like this, it means that there is a multiplication symbol in between these brackets. So first what we have to do is we have to add m plus n together, then x plus y together, then these two terms are to be multiplied together. So that is how this m plus n multiplied by x plus y is evaluated. Then ax squared plus bx plus c, this can be written in C programming like this, a star x star x. So a into x into x. So that is a x squared. Then b into x. So that is b star x plus c. So that is how the arithmetic expressions are entered in C programming. Now we move on to the relational operators. Before moving on to relational operators, let us see how the arithmetic operators work in C programming. Some of the arithmetic operators. So this is in this case the integer a is given the value 21 and integer b is given the value 10. So c equal to a plus b. So it will, the next line will print the value of c. Then again c equal to a minus b. The value will print that this line will print the value of c again. So a minus b. So here it is a divided by b. Sorry, a into b. So it will be how to print 21 into 10. So it is 20. I mean 210. That is what it should print. Then c equal to a divided by b. So here a is 21 and b is 10. So we know that when we divided 21 divided by 10, it should be 2.1. But because this is an integer division, that is happening here? So because both the values are integers, C, a and b are integers, and the result c is also integer. So c equal to a divided by b will give only the value as 2, the integer value of 2. Then c equal to a percentage b, that is the modulo operator. So let's see how this will be working. See the first statement. Line 1 is the value of c is 31 because a plus b is 31. Then the second value condition, a minus b. A is 21 and b is 10. So 21 minus 10 is 11. And here it is c equal to a into b. So a multiplied by b is 210. So that is printed. And as I said in the case, this is, since this is an integer division, here the c value will be only 2. And here it will give you the remainder. This line will give you the remainder, and so it is the remainder of 21 divided by 10. In that case, the remainder, the integer division, the remainder for the integer division. So the remainder for the integer division in that case is only 1. So that is displayed here. So that is about the 5 arithmetic operators. Now we move on to relational operators. The relational operator actually checks the relationship between two operands. That is, it also has two operands, as in the arithmetic operator. The relational operators also has two operands. So the relation checks the relationship, that is between the relationship between two operands is checked, and the relation, if the relation is true, it means if the relation is true, it will give you a value 1. It will give you a value 1. And if the relation is false, it means it returns a value of 0. So that means if the relation is true, then it returns a value 1. And if the relation is false, it returns a value 0. And if an integer is greater, is not equal to an integer, say integer a, if it is not equal to 0, in that case always it is taken as true condition. So if integer is equal to 0, then only it is taken as false. So that we will see. So the operators used in the relational operators are equal to symbol. So equal to means in this case it is comparison. So double in the case of comparison, for comparison or for relational operators, it is given as double equal to. So a equal to b means the value of b is assigned to a. The value of b is assigned to a. So if it is written like this, a double equal to b, this means we are checking whether a and b are equal. So this is the checking whether a and b are equal, and this means we are assigning the value of b into a. So like say here this is given 5 is equal to 3, 5 double equal to 3. double equal to 3 means we are checking whether 5 and 3 are equal or not. We know that 5 and 3 are not equal. So this evaluates to false. This is false. So when this is false, we know that a value 0 is written. So this value 5 double equal to 3 is evaluated to 0. So instead, if it is like a 3 double equal to 3, 3 double equal to 3. So in this case, this is true. 3 double equal to 3 is true. So it will be evaluated to 1. So this symbol is greater than. We commonly use it, the greater than symbol, 5 greater than 3. So this is evaluated to 1 because 5 is greater than 3. So that is evaluated to 1. Since it is true, then this is the less than condition. So 5 less than 3. So this is evaluated to 0 because the 5 is not less than 3. So that that particular condition is false. So this is the relation checking. Relation between two operators is checked, whether it is equal to, whether it is greater than, whether less than. So then the other relational operators, 3 more relational operators are there. That is, one is not equal to. The not equal to is the exclamation symbol and then equal to symbol. So this is the exclamation symbol and then equal to symbol. So that means that is not equal to. 5 not equal to 3. It is again evaluated to 1 because 5 is not equal to 3. So this is evaluated to 1. Then greater than or equal to. So this is checking whether greater than or equal to. In the other case, we are checking whether it is greater than. So in that case, if 5 is greater than 5, this will be evaluated to 0 because it is false. 5 is greater than 5 is false. This will be evaluated to true. 6 is greater than 5. This will be evaluated to 1. But when it is 5 is greater than or equal to 5, 5 greater than or equal to 5, this will be evaluated to 1 because this is false. This is true because 5 is greater than or equal to 5. So this is true and it will be evaluated to 1. And the next relational operator is less than or equal to. Again, less than or equal to is 5 less than or equal to 3. This is evaluated to 0 again because 5 is not less than or equal to 3. So if it is instead of 5, if it was 3, then obviously it would have been 1 because this is true. That is 3 is equal to 3. So there are 6 relational operators are there. One is the double equal to, then less than, greater than, then not equal to, then greater than or equal to, then less than or equal to. So you must remember the order in which these two symbols are inserted. This is greater than first, then equal to. Here it is less than first, then equal to. Otherwise, it won't work. There will be compilation errors may be possible. So let's see a program in which the relational operators are employed. See, here actually 0 and 1 is given. We use some if conditions. So we give two integer values as well as a third integer value is also defined here. So integer a equal to 21 and integer b is 10. So that is the two integer values. Then we check if a equal to b, then printf line 1 a is equal to b. So if it is false, then we have to print line 1 the a is not equal to b. So then the next one is a is less than b. If a is less than b, it is to be print that a is less than b, and else it will be print a is not less than b. If a is greater than b, so this is the symbol a is greater than b. It will print line 3, that is a is greater than b. Else it will print line 3 a is not greater than b. So then we change the value a equal to 5 and b equal to 20. So if a is less than or equal to b, a is less than or equal to b, we print that a is either less than or equal to b. So if b is greater than or equal to a, we print line 5, that is b is either greater or equal to b. So that is the condition. So all the relational operators are included here. So no, except the not equal to is not entered here. See, line 1 is A is not equal to B, and line 2 A is not less than B. 3 line 3 is A is greater than B. Line 4 A is either less than or equal to B. Line 5 B is either greater than or equal to C. So that is how the relational operators work. The relational operators are used. We use the relational operators normally when we have to compare two values. And depending on that comparison, depending on the result of that comparison, we have to take different actions. If A is greater than B, we want to do something, and if A is greater than B, we have to do something else. So that sort of thing. A is greater than B, we have to do something. A is less than B, we have to do something else. So that sort of thing. For that one, we use the relational operators. The next type of operators are the logical operators. Commonly, the relational operators and the logical operators are coming together. So the logical operators, there are actually 3 different logical operators are there. So it is the logical operators are AND, logical AND, as well as logical OR and logical NOT. Logical AND, logical OR, logical NOT. And the logical AND is written with the 2 ampersand signs. Logical OR is written with the 2 pipe signs. 2 pipes, that is just below the backspace character, the backspace key on your keyboard. There is a vertical line, the pipe character. So that is being used. 2 pipe characters are used. Then an exclamation mark is used for not logic. For not, that is the logical not. So in this case, it returns either a 0 or 1, depending upon whether the expression results true or false. So like something like this, we can see an example. So actually the operators and the logical and the logical or logical not is used normally to do expressions or to evaluate different expressions. Consecutive different expressions are evaluated using these 2. Like this one, say for an example, let us see if C is 5, C is assigned with a value of 5 and D is assigned with a 2. Then we check whether this expression C equal to 5, C double equal to 5. So this is evaluated to 1. Since this is true, this is evaluated to 1. And this is logical AND. So AND double ampersand. So that is the logical AND. D greater than 5. D greater than 5. So D is not greater than 5. So this evaluates to 0. So what it evaluates is 1 and 0. So this is it, 1 and 0. So 1 and 0, this gives you the result of 0. Because what it checks is whether this condition as well as this condition, these 2 relations are true or not. One relation is true and the other one is false. So that means if we are taking the AND of that one, the logical AND of 1 true and 1 false, that means it is false. So then other case, OR condition, the logical OR condition, C equal to 5 and D equal to 2. Then the expression C equal to 5. So in this case, in the AND case, both has to be true. Then only it will return true. That is, if both the values are 1, then it will return the value 1. So that if one of them is false, then it will give you false value. So in the other case, in the logical OR case, either of the expressions is to be true, then it will give you a result to true. So here the expression C equal to 5. So C equal to 5, that is true. That is evaluated to 1. Then D is greater than or equal to 5. This is evaluated to 0. But in this case, this is a logical OR. So that means either this function or this expression or this expression is to be evaluated to 1. So since this is already evaluated to 1, this will give you an answer 1. So this is OR. So another condition is the logical note. The logical note in the case, actually whatever condition it gives, it is negated. So like this, c equal to 5, we know that c equal to c is assigned with a value 5. Then in the expression c double equal to 5, this means this is true, that is it will evaluate a value 1. So not of 1, not of 1 means 0. So if this relation is something like c is greater than 5, c is greater than 5 will be evaluating to 0. So that is because it is false. C is not greater than 5, so it is false. So not the c is greater than 5. So this will evaluate to 1 because this is evaluating to 0, and not of it, that is the negation of that one. So that is evaluating to 1. So that is how the logical operators work. So actually there is a truth table associated with the logical operators depending on how the two operators are working. So if two operators, operands, we consider two operands A and B, or this can be expressions also. These two can be expressions also which give the values 0 and 1. So if this expression is false and this expression is false, 0 means false. So A and B, that is the logical and, A and B will be 0 because these two are 0, this will be also be 0. And A or B, this will also be 0 because both are zeros. This A and B will also be 0. And not A will be equal to 1 because A is 0, not A will be equal to 1. And here again 0 and 1. So A is 0 and B is 1. So A and B will be 0 because one of them is 0. This will be 0 itself. That is false. 0 means false. Then A or B will be 1 because B is true and A is false. So one of them is either A is to be false, I mean true, or B is to be true. So B is true. So it is A or B means B is, I mean A or B is 1, that is true. Then not A is again 1 because here this is false, or this is 0. So this is to be true. So that is 1. And A is 1 and B is 0. So A and B is 0 obviously because B is 0, A and B is 0. And A or B is 1 because A is 1, A or B should be 1. And not A should be equal to 0 because A equal to 1. A equal to 1 means not A equal to 0. And A equal to again 1 here, and B is also 1. So both are 1. So A and B is also 1 because both are 1. A and B is also 1. And A or B is 1 because either of these two is to be 1. So but in this case both are 1. So that this is also 1. But not of A is 0 because A is 1, not A is the negation of 1. If A is false, not A will be true, and if A is true, not A will be false. So in this case A is true, so not A is false. So that is how the relational, I mean the logical operators work. So in this case, in this class, we have seen arithmetic operators, then relational operators, as well as the logical operators.